everyone, this is another one of those Narrowboat Tech Talk things. Haven't done one for a week or two. I've been a little bit up to my eyes with it. So yeah, again aimed at you guys that want to understand a little bit more about how your boat works, about how things are connected, all that kind of stuff. So it's a slight diversion for what we normally do in building our boat. So if this video is for you, crack on, keep watching, and if it's not, that's fine. Just skip this one, and we'll catch you again on Saturday, Sunday. Right, so again, laying some of these foundations that we've been talking about already. We've already looked at parallel circuits and series circuits with some of the Ohm's law and power and stuff that we've gone through. Check out those videos, those two videos already there. I want to expand on that a little bit, and we're going to look at batteries in series and parallel, and we're going to look at solar panels in series and parallel, because they're one of the things that are connected up in these ways on a typical narrowboat. So what we got? So batteries. I'm just going to do block diagrams, if that's okay. Batteries in parallel. So 4 batteries, 110 amp hour, 110 amp hour, 110 amp hour, so all the same. Okay, so what I mean by parallel, if these are this is a positive, this is a negative. So positives at the top, negatives at the bottom. Basically, parallel means all the negatives are together and all the positives are connected together. So this goes out to our boat electrics and stuff. So positive, negative. What does this give us? Well, if all of these are 12 volt, which generally they will be, not always, but generally they will be, the voltage here, because they're in parallel, is still 12 volt. Happy days. The current, however, is shared amongst those batteries. So if we pull 10 amps out of here, then each, in an ideal world, which doesn't exist, each one of those batteries would supply 2.5 amps to make up that 10 amps. That's not how it happens, because it depends on the state of charge and stuff. But in an ideal world, that's how that would work. Each one of these would supply some of that current, shall we say, to make it up to the 10 amps. Also, these 110 amps, which is the amount of power it can deliver, amount of current it can deliver over a certain amount of hours, is sort of added up. So in this case, 4 110 amp hour batteries would actually give you a battery bank capacity of 440 amp hours. We're not getting into how much we use and how much is available and all that sort of thing. But that's batteries connected in parallel. The voltage is still 12 volt, the same as each battery. The current is shared between the batteries, and the amp hours, the battery capacity, is added up, summed up. Okay, so what if we connect 2 batteries in series? Can you see that? Yes, you can. I'll bring that over this way. So positive, negative, and positive and negative. So you connect the positive, the negative to the other battery. You can see the current would flow, as convention says, in that direction. So if this was a 12 volt battery, this was a 12 volt battery, 110 amp hours, 110 amp hours. What would we have here? Well, in a series circuit, we actually now have 24 volts. Okay, so the voltage is summed together to give you an output voltage from that battery bank. the capacity remains the same. So that battery bank would be 110 amp hour at 24 volts. The current, again, remember our series circuits is the same as this current flows is the same, the current that flows through both batteries. So if we had 10 amps here, then that 10 amps is flowing around the circuit through each of those two batteries. Of course, we could put another battery in and we get 36 volts, and another battery in and we get 48 volts. Okay, so you would think, well, why would you do this? Well, simple really. If we double the voltage, we actually half the current. So if the same load was here, if we had the same load on here, this current would actually be only 5 amps. You know if that makes any sense? Double the voltage, half the current. That works all the way through. But the power, if you remember the power triangle, the power is the same. The power delivered, the work done is exactly the same. So you often see on, I would imagine, 95% plus of boats, narrowboats, this is the arrangement you see. Batteries connected in parallel, so our output voltage from the bank is 12 volt. And each of those batteries contributes to the current being taken out by the boat electrics or whatever. In some boats you would see this arrangement going up to 24 volts. Just for clarity, the reason you would do this is you can see that current would be half for the said load, so you can reduce all your cable sizes down along the boat. So the same power, the same work done, but of course the current is halved, so you can reduce your cable sizes. So in bigger systems, you tend to see this more. Big inverters, you would go up to 24 volt, 48 volt and reduce those cable sizes. Okay, batteries in parallel, batteries in series. Something else that you will see on your boat, you can see no expense was spared on the technology available. Roll of paper in the fridge. Solar panels. Solar panels, I was going to say are almost like batteries. They're not. They give a voltage output and a current output. Okay, so we're just going to do a mock. Let's say each of the we've got some panels that give out 20 volts, 10 amps. Okay, so some fictitious panel. Let's say they're 100 watt a piece as well. That might make life easier or more complicated for me. We'll see. If we have, and we're just going to work with 2 panels. If we put 2 panels in parallel, so a bit like our batteries, they have a positive and a negative, positive and a negative. The 2 positives together go out, and our 2 negatives go out, generally to a solar controller. What would we have here? Well, we'd have 20 volts and a maximum current delivery of 20 amps. Okay, and still 200 watts of solar. That remains constant anyway. This is fine. This is fine until we start to add more solar panels. So if we added another one, we would be still 20 volts and 30 amps maximum delivery from those panels on that sunny day that we don't seem to have today. Okay, that's fine. We just have a controller to suit those numbers. Well, not so fast. The plugs that you come with solar panels and plug into some controllers are called MC4 connectors. Okay, so MC4 connectors have a maximum current of 30 amps. Can't remember if it's 30 amps or 32, but I always work on 30 amps on the safe side. 30 amps. So if we were to add another panel, we're right on the edge of what those plugs can actually carry. So what do I do? What do we do? We connect those panels in series, similar to our batteries, positive and negative. Hope you can see that. I'm slightly on the slope, but there you go. I think you can see that. So 2 panels, and we connect them the same way, exactly the same way as our batteries. So what do we have now? Same as our batteries now. We have 40 volts and 10 amps maximum. Still 200 watts of solar. Do you believe me or not? Okay, so this would actually give us the same power as this circuit, but the current is halved again. The current is only 10 amps. So the 200 watt might be. So let's just work that out on these numbers. So P equals I times V. So in this circuit, it would be 40 times 10, which is 400 watts. So yeah, I should have changed those numbers really if I'd have thought about it, which I didn't. And this one, 20 times 20, is still 400 watts. So actually these panels would actually work out at 200 watts a piece based on those numbers. Okay, so that's fine. I hope I haven't clouded the waters there too much. But you can see, even though if I connect them in parallel or series, the power delivered to the charge controller is exactly the same. But there's only 10 amps now flowing in that circuit. So down your roof, you haven't got great big fat 20mm cables or anything. You can get away with generally much less than that. I'm not going to say exactly how much because it would depend on the length of the cable, which we will cover in a future time. But with this, remember when I said I added another panel, we're right on the edge of this 30 amps that those plugs can take. We can add another panel and we go up to 60 volts, but we're still 10 amp. So another panel, 10 times 60, 600 watt. We are still developing the same amount of power to our solar controller, and hence our batteries, than we were with these. But of course the current is much less. So this is what I do with all the big panels, the bigger panel installations. We series them up. Now there are some dangers involved in those panels. So 20 volts, still potentially lethal. But of course, when we start to add 4 panels, 5 panels, 6 panels, these voltages get to quite a big number. And I've installed some that are well over 100 volts, which could give you a nasty oomph. So we have to think about things in a little more depth, that these voltages are quite high. But the current is, like I say, the current is minimized. So that's a very quick one. We're at 13 minutes or so. Done all this in one hit by the look of it. So let's just recap a little bit. Solar in series, still the same power. Power is added to, the current is added together. And, see, start that again. 2 panels in series, the voltage is added together and the current remains the same through each panel. Okay, current's low, voltage is high. Panels in parallel, the voltage supplied is the same as the design voltage on the panels, but the current is much higher, so double what this one would be. Of course you can do hybrid circuits, a bit of series and parallel, but I'm not going to go into that right this second. So trying to keep it, so these are our building blocks of electrics. How can you wire up panels if you don't know what the consequences are? And just to recap a little bit, if you can see down here, again looking at our batteries, just recapping a little bit. batteries in parallel, we add the storage capacity together. So each one of these is 110 amps. You get 440 amp hour of storage capacity with those batteries. The voltage in parallel is 12, and the current is delivered by each one of the batteries in some ratio. In a perfect world, each would give the same, but they don't. When you put batteries in series, we add the voltages together. So in this case, 24 volts, and we halve the current, or we reduce the current. If we added another battery, we'd get 36 volts and reduce the current by 2/3. So it would only be 0.3 of an amp, 3 amps, 3.3 amps for a given load, as we've said in this example. Right, hope that's something like. No, very little editing anyway. Just a quick, again, some groundwork. We'll talk about battery capacity. We'll talk about batteries. We'll talk about solar panels and controllers and charge controllers and all that kind of thing going forward. But again, this is groundwork. What happens when you connect batteries in parallel? What happens when you connect batteries in series? What happens when you connect solar panels in parallel? And what happens when you connect solar panels in series? So there you go. So a quick one, a quick 17-minute jobby. So that's it for this one. This is our Narrowboat Tech Talk. That's the playlist it goes into. Feel free to buy me a coffee if that's been useful. There's a link below. If you don't, that's fine as well. That's fine as well. If you want to keep, if you want a notification of these future Tech Talk videos that I'm doing, then please subscribe and you'll get notified of when these are up. Right, okay, great. So batteries and solar panels in series and parallel. Hopefully that's cleared that up for you a little bit. Comments below, happy to answer those, happy to think about them, chat about whatever. So yeah, thanks very much for watching. Hope that's been useful for some of you. I'll see you next time when we'll be talking about something else. Don't know yet, but as things crop up, I'll do those. Okay, right, I'll see you next time. See you then, bye.